Imagine waking up tomorrow and the temperature outside is minus 40 degrees. Your power is gone. Your heater doesn't work. Your phone is almost dead. And within a few hours, the warm room you're sitting in starts becoming a refrigerator. For us, extreme cold is usually a disaster. For Ice Age humans, it was Tuesday. They lived through winters that could become brutally cold without central heating, electric blankets, insulated houses, or even modern fabric. So how did they do it? The answer isn't that they somehow became immune to the cold. They became extremely good at controlling heat, and some of their solutions were surprisingly sophisticated. Start with the thing covering your body: clothing. It's easy to imagine an Ice Age hunter simply throwing a thick animal hide over his shoulders and walking into a blizzard. But that wouldn't be enough. A heavy hide can block wind. It doesn't automatically make a great thermal system. The real trick is trapped air. Air is a terrible conductor of heat, so prehistoric people learned to build clothing in layers. Animal skins could be arranged so that one layer held warm air close to the body, while the outer layer helped block wind, snow, and moisture. And the details mattered. Needles made from bone allowed people to sew fitted garments. Animal sinew could work as strong thread. Fur could be positioned strategically instead of simply being used as one giant piece of hide. Think about what that means. They weren't just wearing animal skins. They were engineering insulation. And then they faced an even bigger problem. Your clothing can only do so much if the wind is constantly stealing your heat. So they changed the environment around themselves. Instead of building a normal house directly on the frozen surface, some prehistoric communities dug into the ground. These were pit houses and other partially underground shelters. And this is where the earth itself became part of the heating system. The surface could be brutally cold, but underground, temperatures change much more slowly. The deeper you go, the less directly you're exposed to the violent swings of the weather above. Now imagine a shelter partly buried beneath the ground. The wind can't blow directly through the walls. The surrounding soil provides insulation, and the roof can be covered with layers of turf, vegetation, hides, and other materials. Suddenly, the humans inside aren't trying to heat an entire frozen landscape. They're trying to keep a small pocket of warmth alive. That's a huge difference. A fire inside a terrible shelter wastes heat. A fire inside an insulated shelter becomes useful. And this leads to one of the cleverest tricks. They didn't always need the fire to keep burning at full strength all night. They could heat something else: large stones. Put a dense stone into a fire long enough, and it absorbs a huge amount of thermal energy. Take it out, wrap it carefully, and that stone can continue releasing heat long after the flames disappear. In other words, the stone becomes a battery. Not an electrical battery, a heat battery. Some traditional cold climate technologies used heated stones in ways that could warm sleeping areas or cooking spaces. And the principle is incredibly simple. Store heat when you have plenty of it. Use that stored heat when you don't. That's basically the same problem modern thermal storage systems are trying to solve. But here's where the survival challenge gets even stranger. You can protect your body from the outside. You can heat your shelter. But eventually, you still have to fuel the machine inside you, your body. Cold weather is expensive. Maintaining your core temperature takes energy. And when you're also hunting, walking, carrying supplies, and surviving in a harsh environment, your food requirements can become enormous. So Ice Age people needed food that packed a lot of energy into a small amount of space. One famous example is pemmican, a long-lasting mixture traditionally made from dried meat and rendered fat. The meat provides protein. The fat provides concentrated energy. And because it can be stored and transported, it's especially useful when fresh food isn't always available. Think of it as portable fuel for a human body. And that word matters. Fuel. Because surviving extreme cold isn't only about stopping heat from escaping, it's also about producing enough heat in the first place. Now there's another problem you might not think about. Water. Look around an Ice Age landscape. Snow everywhere. Frozen rivers. Frozen lakes. It seems like you'd never run out of water. But frozen water isn't automatically drinkable water. Your body still needs liquid. And simply eating huge amounts of snow isn't an efficient solution. It takes energy to warm that snow and turn it into usable water. So people developed ways to melt ice and snow using fire-heated stones, containers, and stored heat. Some cold climate peoples also carried liquid water close to the body to help prevent it from freezing. Again, notice the pattern. They weren't fighting nature with machines. They were exploiting physics. And the same thing happened with their hunting equipment. Extreme cold doesn't just attack humans. It attacks technology. Wood can become more brittle in freezing conditions. Materials behave differently. Adhesives can fail. A weapon that works perfectly in mild weather might become unreliable in severe cold. So prehistoric hunters developed composite tools using combinations of materials. Wood could be reinforced with materials such as sinew, horn, or other animal products. Different materials have different properties. Combine them intelligently, and you can create something stronger and more flexible than any single material alone. That's not primitive thinking. That's materials engineering. And then the sun disappeared. For people living at high latitudes, winter darkness could become another serious challenge. You can survive the cold and still be trapped in darkness. So they needed artificial light. One solution was the fat lamp. A simple stone lamp could hold animal fat or blubber with a wick. Once lit, it produced a small but steady flame. It wasn't just a flashlight. Inside a sheltered space, that little flame provided light, a small amount of heat, and the ability to continue working after sunset. Now step back and look at the entire system. Clothing traps heat. The ground blocks wind and slows heat loss. Stone stores heat. Food provides metabolic energy. Containers provide water. Composite tools keep hunting possible. Fat lamps provide light. None of these technologies looks like a modern furnace. And that's the important part. Ancient humans didn't necessarily survive extreme cold by creating enormous amounts of heat. They survived by becoming incredibly efficient at not wasting it. That's the twist. We often imagine technology as something that gives us more power. But some of the oldest technologies did something completely different. They reduced the amount of power you needed. An underground shelter doesn't create warmth. It stops warmth from disappearing so quickly. A fur garment doesn't make your body hotter. It slows the escape of the heat your body is already producing. A heated stone doesn't create new energy. It stores energy you already generated with fire. And a high-energy food doesn't protect you from the outside. It gives your internal furnace enough fuel to keep running. Put all of those systems together, and something remarkable happens. A landscape that looks almost impossible to inhabit becomes survivable. The Ice Age wasn't a world where humans simply froze and somehow got lucky. It was a world where humans learned, generation after generation, how cold worked. They watched materials. They watched animals. They watched fire. They learned where heat disappeared. They learned where it stayed. They learned how to store it. And they built their lives around those lessons. You and I have heaters that can warm an entire house with the push of a button. But remove the electricity, and that system suddenly becomes useless. An Ice Age human had no button to push. They had something else. A deep understanding of the environment around them. The strangest part is that their greatest invention may not have been fire. It was learning how to waste less of it. Because when the world freezes around you, survival doesn't always belong to the person who can make the most heat. It belongs to the person who knows how to keep it.